do 5 examples together of factorizing by using grouping. We're going to start easy, and then we're going to make it a little bit more challenging, maybe where we need to consider the signs, and I know that students often struggle with this. Let's go. If we look at the definition, what are we doing with grouping? We are going to group terms in pairs, and then we're going to factorize them by taking out a common factor. So if we look at number 1, we can see that there are 4 different terms. Now, if they all have the same common factor, we don't even have to group. We can just take out that common factor and that's fine. But as you can see there, all those terms don't have the same common factor. So we are going to have to group terms together that actually has something in common. Let me show you what I mean. So if we look at the first 2 terms, there we've got a 5 and a 5. So if we put term 1 and term 2 together, we'll be able to take out a common factor of 5. If we look at term 3 and term 4, well, there they've got a t in common. So if we group together term 3 and term 4, we'll be able to take out a common factor of t. We're not going to group terms together if they don't have something in common that we can take out. Now, I see my students skipping the first step where they actually show how they're grouping these terms together. They just go straight to, okay, I'm taking out a 5, and then that will be left. And even though that's fine, when we get to more challenging sums, I find that they make sign errors and silly errors when they don't show this first step. So I would encourage you to show this first step. I take term 1 and term 2 and I group them together. There, I just group them. Then we are going to put term 3 and term 4 together. Now, this is a basic, easy example because I'm just dealing with addition. I'm just dealing with addition, and I'm going to highlight when we're also dealing with negative signs, how we're supposed to deal with that. We'll deal with that later on. Now, we can take out a common factor in the first term. I'm going to take out my 5 because now this whole thing is term 1 where I can take out a common factor, and that is term 2. So I'm taking out my 5, and then there will be left x plus y. And in the second term, I take out a common factor of t, and then that is y plus x. Now, do you see that these brackets are just exactly the same? Because we can turn that y plus x around. They're exactly the same. For addition, we can do that. So we can take out the common factor, x plus y, from both terms. Then we are left with, in the first term, 5, and we are left with, in the second term, t. And there we factorized it by using grouping. Let's just recap. We grouped the terms together that's got something in common that we could then take out as a common factor. After we've taken out a common factor, then what we can do, there's the common factor that we took out. Then we can group because our brackets ended up being exactly the same. If you land up with brackets that are different, we need to try and group the terms differently. So in other words, then you could consider grouping term 1 and term 3 and term 2 and term 4. That can also happen. But I would suggest to always start by looking and seeing if it's possible to group 1 and 2, and then 3 and 4, explore, and then take it from there. Don't be discouraged if you try it and it didn't work out. Just try again. All right, let's look at the next one. Is there something that all 4 terms has got in common? They definitely don't. We can't take out, no. Oh, I thought for a moment 3, but I was wrong. Okay, so let's group them together. Do you think it will work if we group the first 2 together? Let's try that. If it doesn't work out, we just try again. We try something else. We group them differently if that does not work out. So I'm grouping the first 2. Now with this one, I want you to pay special attention and be careful because it isn't a plus in between. So I just can't go and put brackets around something without considering the signs. Now note, in the original sum, we've got negative 16x and we've got plus 12. We can't just change to the sum. So we need to stay true to those signs. If I leave this as a negative, like it was over there, if I leave it like that and we multiply it out, we get negative 16x, which is fine. But if I multiply that out, I get negative 12 as well, which is not true. Do you see that? We need to get back to plus 12. We can't just change to a sum. So what will happen in this case is that inside the bracket, the sign will change to a minus instead of the plus that it used to be. Why? Because if I multiply that back out, it's minus 16x. And if I multiply that back in, it gets me to plus 12. So both of those work. So we didn't change to the sum. We are just rewriting it in a way that suits us so that we can factorize. But we're not changing to the sum. Okay, perfect. Now let's take out a common factor of the first bracket. That would be x squared. Then we're left with 4x minus 3. For the second bracket, what can we take out there? A common factor of 4. Then we are left with 4x minus 3. Now, I think this grouping works out well. Do you see that? Because we've got common brackets that we can now take out again. So, from there to there, we took out a highest common factor in each bracket. And now from here to there, we're going to take out a highest common factor again. But in this case, the common factor is just a whole bracket. So let's take that out. 4x minus 3. And then left over in the first term. And then left over in the second term. And there we factorized using grouping. But let's just have a quick squiz there. Is it fully factorized? Do you see that second set of brackets over there? That fulfills the conditions to factorize it using dots? Because do you notice there that we've got a perfect square there and we've got a perfect square there and they are separated by a minus. So we can use dots. So 4x minus 3. This bracket over there will break up into two sets of brackets. The square root of x squared is x. The square root of 4 is 2. And 1 plus and 1 minus. And now it is fully factorized. So this is a lot. We're doing all the things. We first grouped, took out a highest common factor, then took out a common bracket, and then we did dots. Now for this one, this looks like a good example where it won't help us to group the first two together and then number 3 and number 4. Why not? Well, because the first two, they don't have a common factor. And 3 and 4, they also don't have a common factor. So it won't help to group them together. We literally won't be able to go further. So let's explore and see how else we can group these together. What do you think about maybe grouping 1 and 3 together and then 2 and 4? Let's explore. I mean, we'll just try something else if it doesn't work. So I'm going to take term 1 and there is term 3. And that is why I recommend showing this step. Otherwise, we just get confused. So I put those together and then there's going to be a minus in between because of that, right? That is the sign that belongs to our B there. So there must be a minus in front and then it would be B. And now this is the example, like with number 2, right? Where the sign in the middle then will have to change to a plus. It can't stay a minus there because now if we multiply it back out, we're going to land up with minus B, which is great. That's what we want. And then we're going to land up with minus 1, which is great. That's what we want. But if we did not change that sign in the middle, then it wouldn't have worked out. We would have changed to the sum, and we can't change to the sum. We are just rewriting it in a way that suits us. Now, I know that some of you could say, but why did you put 2 and 4 together? Because they don't have a common factor. But let's just work with it before we try something else. If I take out a common factor of A there, then I'm going to be left with 1 plus B for the first bracket. And then, well, there isn't a common factor, so that just stays the same. And this would work nicely. Do you see that? Those brackets are exactly the same. For addition, we can just swap them around. So our common factor would be B plus 1. And left in the first term is A. That looks more like a 9. Let me just do better there. A and then subtract 1. There we go. And there it is fully factorized. I want to encourage you to, when you look at these sums, put your thoughts on paper. Write it down and see if it's working out. If it's not working out, try something else. But don't just try and do it in your head and then just say, oh no, I don't think it's going to work out. You have to put your thoughts on paper. Don't try and figure it out in your head first before you start writing anything down. Write as you go. Put your thoughts on paper. It's such a good strategy. Show your thinking. All right, number 4. Do you think it's going to work to put number 1 and number 2 together? I don't know. Number 3 and number 4-ish? I don't know. So I'm seeing a few interesting things that we need to try. If I put 1 and 2 together, that bracket will actually give me dots. I want us to try a few things with this one. Let's see what happens when we do that, and then we're going to try something else, because maybe you would think that we could put those two together because they've got a common factor, and then these two together because they've got a common factor. Let's do it in both ways and see what happens. All right, let's firstly do it where we put the first two together. I don't think a lot of students would have opted for this one. Okay, so we grouped 1 and 2 and then 3 and 4. Let's see for the first one. Do you see that this is dots? Those are both perfect squares, so that will break up into two sets of brackets, x and x, 2 and y, 2 and y, 1 plus and 1 minus. And do you see, now that we evaluate, so in term 1, we've got those two brackets. Do you see that that bracket is exactly the same as that bracket? So we've got a common bracket there that we can take out. There is our common bracket that we took out of term 1 and 2 that they had in common. And then left over in the first term, we've got that bracket, x plus 2y. And left over in the second term, don't say nothing. Remember that imaginary coefficient of 1 there. We've got plus 1. So note what I'm doing over here. There's my main brackets. And then inside there's some more brackets, which just represents this leftover in term 1. We don't want brackets inside brackets though. So let's just get rid of that. So brackets inside of brackets, we would just land up with x plus 2y plus 1. It looks like I'm just removing the bracket, but that's because there's an imaginary coefficient of 1 in front of that bracket that if we multiply it back in, it will just stay exactly the same. So that one is fully factorized. That is method number 1. Some might find it a little bit complicating. I don't know, that's fine. You decide what you're going to go for. With this one, we said, let's try and put those two together because they clearly have a common factor of x. So let's just show this step where we show what we are grouping together. We're grouping that. Now be mindful because there's a minus in between there. So we are going to have to change this sign in order that we don't change to the sum. Because if we multiply it back out, we are staying true to these original terms. Let's take out a common factor of x there. Then we're left with x plus 1. Over here, we can take out what? 2 and a y. And then we will be left with 2y and then plus, well, 1. Do you see that this is not going to work? Because we actually don't have a common bracket. So then we won't be able to go any further. Okay, so method 2 was just eliminated. Shall we try one more time and group something differently? Shall we try and group this one and that one? That's not going to work. No, this was actually, number 1 was actually the only option. So this one is quite tricky. Remember in the beginning of the video, I did say that we're going to start out simple and easy, and then we're going to make it a little bit more challenging. And I do think that this is, it's not that challenging, but if you can spot the idea of dots forming over there, I think you would find this pretty easy. So the more we practice these things, the better we get at it. One more. Now, number 5 looks crazy long, but let's just see what is going on. When you see something like that, don't let it overwhelm you. Let's just break it down. There we've got one term over there. I know most of you would want to multiply that in. You are going to go into simplify mode and you're going to multiply that in. But let's just pause. Remember, the question is that we're supposed to factorize. So we're just considering methods of factorization. Now, if we look at term number 2, well, there's some potential there. Why do I say that? Well, these brackets are already exactly the same. So we can take that out as a common bracket. Okay, that's good. But then we've got this random on its own and this little thing on its own. So let's group them together. Because do you see the potential there? In this bracket, we've got a P and a Q. There we've got a P and a Q. And here we've got a P and a Q, even though they're the other way around. Maybe we can try and do something. And this is also a perfect example where don't try and do everything in your head and then start feeling like, I don't know. Put your thoughts on paper. You can just scratch it out and start over if it's not working. So let's put our thoughts on paper. I'm just going to write this over for now because there's nothing I can do yet. Because remember, in order to take out a common factor, all the terms must share that common factor. So we can't go and take out the P minus Q just yet. Let's group those two last terms. So be mindful, there's a minus in front. So if I do that, I have to change that sign in order to stay true to our original terms. When I multiply that in, I'm going to get that, which is exactly what we had in the beginning. If we don't change that sign, we're going to change to the sum. And I know that sounds actually pretty crazy because we're changing to a sign and we're saying we're not changing to the sum. But when we change that sign and we add the brackets, we're actually staying true to the original sum. Now let's check this step and see if something is falling into place. P minus Q, P minus Q, Q minus P. So this is the other way around. And remember, when there is a minus in between, we can't just go and swap them around like we can with plus, right? If this was Q plus P, we can just go and swap that around, but we can't do that for subtraction. Do you remember the video earlier? If you didn't watch that video, where it was about taking out common factors, taking out common brackets, do go and watch that video. So in order to swap these two around, that the brackets are identical, it is as if we are taking out a common factor of -1, which will then change the sign in front. So what is the shortcut? If I want to swap my two terms inside the bracket, if I want to swap them around, literally just swap them around, then the sign in front needs to change. If I multiply this back out, I get plus P. And if I multiply this back out, I get minus Q. Do you see that we are still staying true to what we originally had? Negative Q and plus P. So we are swapping things around, we are changing signs, but we are staying true to what we had in the beginning. I'm just going to repeat that shortcut. If you want to swap terms around inside a bracket to make it look like other brackets, P and then Q, we literally swap them around. Then the sign in front, whatever it was, needs to change. If it was a plus, it would have become a minus. Okay, phew, let's go show that step. X squared, P minus Q minus 2x, P minus Q. Oh my gosh, what is going on with my Q's? And then P minus Q, and then the sign in front changes. Now, so far we haven't even done any factorization. We literally have just been grouping and making things the same, creating common factors, so that now, finally, we can take out this common bracket. And remember, we must be able to take out the same thing from every single term. There's our common factor. Let's take it out. P minus Q. What is left in the first term? X squared. What is left in the second term? That. What is left in the third term? Don't say nothing. There's an imaginary coefficient of 1 there. Okay, so finally, we did some grouping, we took out common factors, but now we need to check and see if we have, in fact, fully factorized this. Let's see. Well, that is pretty much done. Let's look at this. Is this a trinomial that we can maybe find some factors for? Let's have a look. P minus Q, and you haven't already and you're struggling with this, do make sure to watch the videos on factorizing trinomials. The factors for this would be 1 and 1, because 1 times 1 gives you 1, and then we've got x. And how are we going to get to the middle term of -2? Well, it has to be a minus 1 and a minus. And now it is fully factorize. Again, a lot going on, but I know that you can do this.